I've mentored many JavaScript developers, and when you do that, you'd be surprised how many of them have an incomplete understanding of how promises in JavaScript work. For junior developers, that is obvious, right? Because promises can be quite confusing. But even senior developers don't know the 3 ways that you can create promises or how you can compose them using promise composition. And I'm not talking about .then like piping here basically. I'm talking about actual function composition applied to promises. So I wanted to shoot this video so that you get a holistic understanding of promises, so that when you find them in code, then you can focus on the logic instead of trying to understand what's going on with the promise. And the first question that we're going to answer is, what is a promise? In JavaScript, a promise is an object that represents the eventual completion or failure of an asynchronous operation. You can kind of think of it like a placeholder for a future value. And the first way that you can create promises is using the promise constructor. The promise constructor receives a callback function called the executor function. And this executor function receives 2 parameters. The first one is the resolve function that you can use to tell the promise that it should be fulfilled. And the second parameter is the reject function, which you can use to tell the promise that it should reject. Here's an example. Create a promise using the new keyword, and then in the executor function, use the resolve parameter to tell the promise what it should resolve with. In this case, the string hello world. It is important that you differentiate between the promise constructor and the promise instance. The promise constructor refers to the class after the new keyword, while the promise instance is what gets returned and captured in the resolving promise variable. I wanted to differentiate the two clearly because many developers call both of these things promise, and now you can also differentiate between and be precise in code review or if you ever need to discuss something like that. But you will find that in the real world, developers call both of these things promise and they don't differentiate between them explicitly. Now, here's what a rejecting promise looks like. Now, to create a rejecting promise, you take the second parameter of the executor function, called the reject function, and you pass it the value that the promise should reject with. In this case, something went wrong. It is convention that you leave the first value as an underscore if you don't use it, so that other programmers know, yeah, you're not using this one. But if you want to, you can use both, and we're going to look at example where you use both in the same promise later in this video. Promises are chainable, and this is called promise chaining. Sometimes developers also refer to it as promises are pipeable and promise piping. They really use these terms interchangeably. And the basic gist behind it is that you can handle the results of promises sequentially by using method on the promise instance object. The first method is the .then method that allows you to handle the resolved values. Then you also have the .catch method that allows you to handle the rejected values. And then there's also the finally method that always runs no matter what. So let's take a look at the .then method first. It receives a callback function, which in turn receives the resolved value as its first argument. Create a new promise that immediately resolves with the value hello world. Now you can attach a .then method that receives this value when the promise resolves, so that you can log out the result. You can also use the .then method to handle rejecting promises. For that, create another rejecting promise. Now attach the .then handler, but leave the first parameter as null because you're not going to use it. Now you can use the second parameter to handle the promise rejection. This allows you to handle both fulfillment and rejection using the same method. You can also pass in the handler to the methods in point.free style. Create a new promise that resolves immediately. Now pass in console.log directly to the .then method. This is called point.free style, which is when you use or define a function without explicitly mentioning its arguments. Console.log will just receive the resolved value from .then. Now let's also take a look at the .catch method, which is arguably the cleaner way of handling rejecting values. Here's an example. Create a rejecting promise. Now attach the .catch method to the promise object. It will receive the rejected value so that you can log it out or do whatever with it right in the real world. This is arguably a lot cleaner than using the .then method's second parameter, and most developers prefer to use the .catch method. Now for the third method, let's talk about finally. Finally runs regardless of the result, which is super useful for cleanup tasks when you're using promises. Create another resolving promise, and now attach a .then handler and log out the result. Then attach another finally method, and this finally method will run regardless of the outcome of the promise when it settles at the end of the chain. Now that you understand promise chaining on a basic level, I want to show you some complex examples, because ultimately I want you to understand 4 different behaviors in promise chaining. The first one is that if an error is thrown in a .then handler, then this error bubbles up and skips the subsequent .then handlers until the second behavior kicks in, which is when you catch that error with another catch method or the second argument of a then method. Now the third behavior kicks in once the error was caught, which is now all of the then handlers are triggered again. The subsequent .then handlers handle the next values. Okay? And then the fourth behavior is that when you pass values like that through the promise chain, you can also modify those values. Here's the first example. Define a query trace function that first takes in a message and then a value, and then it logs out the message and the value. Now you can define a promise that immediately resolves with 1 and attach 2 then handlers that will both log out the value. When you now run this code, you will see that it first says first 1 and then second 1. Now let's take a look at what happens when you throw an error in a .then handler. You can define a trace function again and then define a throw error function. Now create a promise that rejects with the value 2 and use the throw error function in the first .then handler. The second .then handler will be skipped because now there's an error in the chain, and the catch handler at the end that you're going to attach third, it will handle the error actually, it will actually receive it and log out the value. So when you run the code, what you see in the console is the caught error and the number 2. The second .then handler is not executed because there's an error in the chain, so all of the then handlers are skipped until you finally meet the next catch method. Now let's look at what happens after you caught an error, because now you can actually start chaining the .then method again. Start by creating a promise that rejects with the value 3. Now attach a .then handler, 2 catch handlers and another .then handler. When you run this code, you see the initial then handler is skipped because the promise is rejected. The first catch handler receives the rejection reason 3, increments it by 1, logs it and returns the new value 4. The promise is now resolved with 4. Any subsequent catch handlers are skipped since the promise is resolved. The next .then handler receives the value 4. Notice that this example also demonstrated that you can modify values in your promise chain, right? In this case, you incremented the value by 1, and then the incremented value was passed through the chain. Now let's look at one last very complex chaining example. Resolve a promise with 4, then attach a .then handler to it. A catch handler, 5 more then handlers, the last of which uses the second parameter of then to catch any errors, another catch handler, and finally another then handler. When you run this code, you will see first 4, second 4, keep in mind you can change what's being passed through 5, caught through the second parameter error 5, this is the end 5. Here is what is happening step by step. The chain starts with a resolved promise with the value 4. The first then logs out first 4 and then returns 4. The first catch is skipped because there is no error. The second then logs out second 4 and returns 4. The next then increments the value to 5. The following then logs out, keep in mind you can change what's being passed through 5, and returns 5. The next then throws an error with the value 5. The subsequent then catches the error using the second parameter, logs caught through the second parameter error 5, and returns 5. The second catch is skipped because the error has been handled. And the final then logs out, this is the end 5. A promise can exist in 3 different states. The first one is called pending, and the promise is basically in the state directly after its creation, and then it stays there until it finally resolves or rejects. The second state is when it has resolved. You've seen that plenty already, and there's also the onFulfill function, which is typically associated with the resolve function, which is just the name of the callback function that we've used earlier for the first parameter of the .then method. And then you also have the rejected state, right? And you've also seen rejection plenty, but the onRejected handler is something new, which is the name of the function of that second parameter for the .then handler, or the first callback function for the catch method. Now, once a promise has resolved or rejected, we call it settled. And once a promise is settled, you cannot change its state again. You cannot resolve it again. You cannot reject it again. That means that once the promise state is reached, it is immutable and cannot be changed again. Another important aspect of promises is that you cannot introspect the state. So you can only observe the effects by using .then and catch handlers, and you can define the behavior, but you cannot ask the promise, hey, in what state are you? You can observe the 3 different states of a promise by creating a new promise called pending promise, which is initially in the pending state. Next, log pending promise immediately, which shows promise pending after 1 second. You resolve the promise with fulfilled. When you now log pending promise using the .then method, it shows promise fulfilled after 1 second. Now you can tie everything that you've learned so far together and create a little waitFor function. So it's important to notice that the examples that I'm giving you here are just to solidify your understanding. They have no real-world application, right? But you will get plenty of real-world practice by just building apps, so do that instead. I hope these help you to understand promises better though. So let's get started. So the waitFor function takes in 2 parameters, the value and a time in milliseconds. And then it uses the setTimeout function to resolve with the value if it's truesy and reject with the value if it's falsy. It's important here that you use the return statement before both the resolve and the reject function, because otherwise the promise will fall through, right? Similar to a fall through in a switch case, and it will trigger both the resolve and the reject function, which can lead to unexpected behavior. Now, promises are eager, and eager here refers to the evaluation behavior of promises. And the evaluation behavior of anything in JavaScript or in programming can be eager or lazy. Eager means that the computation is executed immediately, while lazy means that the computation is executed when it's needed. Now you might be asking yourself, wait, I thought promise has something to do with some future value, right? So how is it eager? Well, let me explain. Here's what it means for promises. Start by just logging out before promise as a string. Then create a new promise, and in this promise you log out something and then you resolve with the string. Now, before attaching a .then handler, call console.log 1 more time and then log out the result of the promise. When you run this code, you get the following output. What gets logged out is before promise, inside promise, after promise, and then the resolved value. And what's interesting here is that inside promise is logged out immediately after before promise, but before after promise. I know that sentence was a little bit confusing, but just hit the left arrow key to hear that again. So the point here is that promises are eager, and the value inside of the executor function, the console.log, is executed immediately when the promise is defined. And that is what it means when you say promises are eager. If you are curious and you want to see something lazy, then check out my video JavaScript Generators Explained but on a senior level, which shows you generators, and generators are something in JavaScript that is lazy. Now let's talk about promise methods some more. And I'm not talking about the methods that you've already saw, then, catch, and finally, which are methods on the promise object. Now I'm talking about methods on the promise class. And that's why we made that distinction in the beginning of this video, so you know the difference between the two. Because they have different methods and they expose different methods. And if you confuse them, you might try to call a method on something that doesn't exist, right? So the first method that we want to talk about is resolve. And there are actually 2 static methods that I'm going to show you both that allow you to create promises in a different way, which is the second way to create promises. So this resolve method is different from the promise constructor because the promise constructor receives a callback, while this promise method just receives a value. And it receives the value that it should resolve with, and then the promise resolves immediately. Create 2 promises. Create the first one using the promise constructor like you're used to, and then create the second promise using the new resolve method that you just learned about. And both of these promises actually behave this exact same way. They're equivalent. But now let's look at also the reject method, which is another static promise method that you can use to create promises that reject immediately. To show this behavior, create another promise again using the constructor method, but this time again use the second parameter to make the promise reject. But you can also create that same promise using the .reject method on the promise class, right? And again, both of these promises behave equivalent, and you need to use catch to get the value of both of them. Now, the promise class also exposes more methods. Obviously, it has the methods that we just looked at that you can use to create promises, but it also exposes methods to handle multiple promises at once. The first method is the .all method. It receives an iterable of promises, and then if all of those promises resolves, it returns an array with the result of all of these promises. Create a helper function wait that takes a value and a timeout. It returns a promise that resolves after the timeout. Next, create an array promises with 2 promises. One resolves after 2 seconds and the other after 1 second. Then you call Promise.all with promises. It returns a new promise that resolves when all promises in the array have resolved. The resolved value is an array of the results of the input promises, in this case hello and world. Since the first promise is slower and resolves after 2 seconds, it takes 2 seconds until the promise returned from Promise.all resolves with the array. Now, Promise.all is cool, but the problem with Promise.all is that as soon as one promise rejects, Promise.all will also reject with that same value that the first promise rejected with, right? If other promises reject, then it will ignore those that rejected later, but it will always reject with the earliest rejection value. So, what if you want to just await the results of all the promises, regardless of whether they reject or resolve? For that you can use Promise.all.Settled. It also receives an iterable of promises and then just waits until all of the promises are done, until all of the promises are settled, and then it just returns an array with all of the results. Create 2 promises, one that resolves and one that rejects, and now use Promise.all.Settled to wait for the result of both of these promises. It will return an array containing objects, and each object contains a status property indicating whether the promise was successful or not. But if the promise was successful, it will also contain a value, and if the promise was rejected, it will contain the reason why it was rejected. So Promise.all.Settled is useful when you handle multiple promises and you don't care whether they resolve or reject, you just want to handle them all. There's also a method called Promise.any, which allows you to handle multiple promises and resolve with the value of the first resolving promise, even if others reject before that. Let's look at an example. Create 2 rejecting promises and one that resolves after 100 milliseconds. Promise.any waits for the first promise to fulfill. Since Promise2 fulfills after 100 milliseconds, the .then handler logs success. If you modify the code so that all promises reject, the catch block will handle an aggregate error, indicating that all promises were rejected. Now, the methods that we've looked at are mostly obscure. Really, Promise.all is the only one that is used a lot in the real world, but another one that is also used frequently is Promise.race. Promise.race also takes in an iterable of promises, but Promise.race just returns the first result of any promise. So if the first promise resolves, then Promise.race also resolves. If the first promise rejects, then Promise.race also rejects. And all of the subsequent promises in that iterable are ignored. Create 3 promises. The first to resolve, but the third one rejects. And the rejecting promise should reject faster than those first 2 promises resolve. When you now use Promise.race on those 3 promises, you will see that it rejects with the value of that third promise because it is the first promise that settles, even if it is a rejected value. If you modify your code so that the third promise rejects later than one of the other promises fulfills, then Promise.race will also resolve with the value of the first promise that settles with the resolving value. Change the timeout so that Promise 1 resolves after 50 milliseconds and Promise 2 after 500 milliseconds. And Promise 3 rejects now after 100 milliseconds. Since Promise 1 fulfills the fastest, Promise.race resolves with first. Promise 3 still rejects, but using Promise.race that doesn't matter, and Promise.race just ignores it. 2 more important keywords that you need to know when you work with error functions are the async keyword and the await keyword. They allow you to deal with promises as if they were synchronous. The async keyword is written in front of functions to declare them asynchronous, and the await keyword can be used inside of the function body to pause the execution of the function until the awaited promise resolves. So you write the async keyword in front of the function keyword when you use function declarations, and you write the async keyword in front of the parentheses for error functions when you want to make error function asynchronous. Here's an example. You can create a function called fetchData and use the async keyword to make it asynchronous and to be able to use the await keyword inside of the function body. Then fetch some data and await that promise, and then await the response of the JSON call on that response object, and finally return the resolved data. Because the async keyword makes the promise asynchronous, you can now use .then on the fetchData function to get the result. Usually you need to use the async keyword to declare a function as asynchronous in order to be able to use the await keyword inside of the function's body. But certain JavaScript environments also allow you to use the await keyword anywhere in the code. This feature is called top-level await. With top-level await, you can just await promises in your code directly. So in this case, you don't need to use .then to log out the result of your promise. You can also await synchronous values like strings, numbers, and booleans. Here's how that looks. Write a function await synchronous that awaits a string. Since you're using the async keyword, the function becomes a promise returning function. Then you await the string, which does nothing because all non-promise values behave the same as they usually do in synchronous code when used with the await keyword. If you've worked with JavaScript before, you've probably seen the try-catch syntax, even if you're not very experienced with promises. It can be used to catch errors and handle them, and try-catch is frequently used together with async await. Here's an example. Create a function called fetchData that just fetches some data from some server, and then create another function called getData. Inside of getData, wrap the call to the fetchData function in a try-catch block, and inside of the try, you await the fetchData call. Now, if the fetchData function throws an error because maybe the call to the server fails, the catch block will trigger and handle the error. That means that no matter if fetch succeeds or not, the getData call will always resolve. Now there's a special case that we need to look at, which is when you use the return keyword in front of the await keyword. This makes especially a difference for rejecting promises. Let's look at an example. Create two functions that both ultimately reject the promise, and in both of them you use try-catch. But in the first function, getNumber with await, you await the rejecting promise before returning it, while in the second function you just return the rejecting promise. Now when you use .then to handle the first promise, it will actually always resolve, because awaiting the rejecting promise causes the try-catch block to trigger. Now in the second method, because you're not awaiting the rejecting promise, the try-catch method does not trigger, so you actually need to use the catch method on the rejecting promise to handle that rejecting promise. Now implicitly when watching this video, you've already seen the 3 different ways that you can create promise returning functions, but I want to show them all at once in one example so you can compare them and see the differences explicitly. Async inc1 manually constructs a new promise using the new keyword and the promise constructor. Async inc2 resolves with the promise by using the Promise.resolve method, and async inc3 simply becomes a promise returning function because you're using the async keyword. All of these 3 promise returning functions behave the exact same way and are equivalent to another. And it's important to notice that the third function, using the async keyword, does not use the await keyword. Since x plus 1 is just the synchronous expression, the await keyword would have no effect here, and using the async keyword already makes it a promise returning function. Another important behavior that you need to know about promises is unwrapping. Unwrapping means that when you're using promises using the .then method and the callback function inside of the .then method returns a new promise, then the subsequent .then methods will receive the value that that new promise resolves with. Here's an example to illustrate it. Define 2 functions, inc and async inc. Now resolve a promise with 20 and then chain the inc function and the async inc function respectively and log out the results. Without the unwrapping behavior, you would expect that the second function, where you're using async inc, resolves with a promise pending. But because the value is unwrapped, both actually resolve with the value 21. And await keywords also unwrap. Promise.resolve 20 .then inc returns a promise that resolves with 21. But the await keyword unwraps it so that the example function actually also returns 21. It's important for you to know that promises in JavaScript can neither be aborted nor cancelled. There's no built-in mechanism to do that. But some people abuse the Promise.race keyword to build their own cancel mechanism. Here's how that looks like. Create a function called fetchData, and this fetchData function now fetches some data from some server, doesn't matter too much, but then you also create a timeout promise. And this timeout promise rejects after 5 seconds. You can now use Promise.race to await both of these promises, and if the fetch takes too long, the timeout promise will kick in, reject, and all of the Promise.race in total will reject. Now the problem here is that the fetch request will actually execute no matter what, because remember, promises don't have an abortion mechanism, so it will just run through and you cannot cancel it. Now the only exception is actually the fetch method, because the browser exposes an abort controller. So in general, if you have any other promise like a database request, you will not be able to abort it, but you can abort in-flight fetch requests like this. Create an abort controller and a signal. Use abort controller to cancel the fetch request after 100 milliseconds, which makes it likely that the server hasn't responded yet. While the promise itself isn't cancelled, the underlying operation is aborted and the promise rejects with an abort error. You can handle this error to know that the operation was intentionally cancelled. Now, why are promises even needed in JavaScript? So, Before promises, there was something called callbacks. I mean, we still have callbacks, right? But every asynchronous operation was handled with callbacks, and you had to nest them, which made them very, very hard to read. And promises streamlined asynchronous operation and made them much easier to work with. Here's what it looks like when you had to use callbacks for asynchronous operations. Create 3 functions: get users, get posts, and get comments. And all of these are written in the old school way, where the second argument is a callback. And this callback gets passed 2 parameters. The first is an error if it exists, and the second is the result if it exists, right? And when you now use these functions together, you had to deeply nest them and always check, did you actually receive an error or did you actually receive a result? And developers called this callback hell for a reason, because this nesting gets really ugly. Let's take a look at how you can clean this up using promises. Write a Promisify function that allows you to turn callback functions into promise returning functions. You can now use it in all of your functions and then chain them using the promise chaining syntax. Error handling becomes super easy because you only need to use a single catch method at the end of your promise chain to handle all of the errors arising in any of your functions. Now for the climax of this video, I want to teach you promise composition. But in order to understand promise composition, you also need to understand function composition and functional programming. So go watch my video about functional programming now, if you haven't, because you need that as a foundation for this last part, but I promise you it will be worth it. So in that video, I teach you a function called pipe. And pipe allows you to compose functions in reverse mathematical order. But this pipe function does not work with promises. So in order to compose promises or promise returning functions, you actually need a different function called asyncPipe. You can write the asyncPipe function using async await. Simply make the reducer function asynchronous and then await the accumulator before applying the next function of the function array. Now you can still compose functions like you're used to, and you can also compose in non-promise returning functions, and it will still work. Let's break down how this asyncPipe function works. In the first step, x is 20, so the accumulator y is 22. The current function is asyncInc. So you await y, which is 20, because await of 20 returns 20. You then call f of y, which is asyncInc of 20. This returns a promise because asyncInc is an async function. Note, even if asyncInc was a synchronous function, so just inc, since the reducer function uses asyncInc, it always returns a promise. The accumulator now holds a pending promise from asyncInc 20. In the second step, the accumulator is now the pending promise from asyncInc 20, and the current function is double. You await y, which is await of asyncInc 20, resolving the promise to 21. You then call f of y, which is double of 21, resulting in 42. Although double is synchronous, the reducer function uses async, so the accumulator holds a pending promise of 42. In the third step, the pending promise of 42 is the accumulator, and async square is the current function. You await y, resolving the promise to 42. You then call f of y, which is async square of 42. This returns a promise because async square is an async function. The accumulator now holds a pending promise from async square 42. In the last and final step, the pending promise of async square 42 is returned, and then the .then handler causes the promise to resolve and logs 1764 to the console. Composing promises allows you to chain asynchronous operations in a clean and maintainable manner, while at the same time reaping all of the benefits from functional programming. I love you very much. Thank you so much for watching. If you learned something, subscribe to the channel and give the video a like, it really helps me out. And then go watch this video next, because the YouTube algorithm thinks that you will learn a lot from it. Peace.